All right, let's take a look at filters. There's different ways we can think about filters. For our purposes, this is another way to look at resonances, which we were talking about in a previous video. Um, Looking at it in terms of filters allows us to talk about more properties of the individual resonant frequencies, not just their frequency, but other aspects. And there's some other things that we can capture here as well. Essentially, what a filter is, broadly speaking, is it's something that takes an input sound, ideally with one that has energy at a lot of different frequencies, and it reduces the energy at some frequencies while retaining the energy at other frequencies. And conceptually, we can talk about three main types of filters. There's a high pass filter, which is a filter that reduces low frequency energy while retaining or passing energy at high frequencies. We can talk about a low pass filter, which is just the opposite. It reduces high frequency energy and retains low frequency energy. So for each of those, you have some cutoff frequency. I want to retain the energy on one side of this frequency and attenuate it, cut it out on the other side. And we also need to talk about steepness, because a filter in practice can't just accept all this energy and then completely block out all the other energy. It tends to have a fall off, and the steepness of that fall off is generally measured in decibels per octave. Like for every octave you increase, how many decibels more are you cutting off? Or for a high pass, how many decibels more are you passing? And the third type of filters, we have high and low pass filters, which have cutoff frequencies and steepness. The third type of filter is a band pass filter. And that's one that passes a band of frequencies while cutting out energy above and below that band. And band pass filters are generally characterized by a center frequency and a bandwidth, right? It'll fall off on both sides, and the bandwidth is, what range of frequencies can you get, some, this close to the maximum, right? It'll start cutting off right in the middle, but when does it start getting really, really steep? Okay, so those are our three main types of filters. The vocal tract can be thought of as a complex filter. Uh, it has band pass elements. So if we think of our tube resonances that we were talking about earlier, the individual resonances can each be thought of as a band pass filter. And for a very neutral sound like the schwa, where we have as close as we can get to a uniform cylinder, those band pass filters, their center frequencies will be evenly spaced, following the math formula that we saw earlier. So our resonant frequencies in speech, these are generally called formants, formant frequencies. The formants are the resonances. We also have something when we speak and the sound leaves our mouth, that sort of radiation from the mouth and the nose changes the frequency makeup a little bit. And it tends to increase high frequencies relative to low frequencies on the order of about 6 decibels per octave. So you could almost think of that as a high pass filter, like it's got a gradual slope and it's preferring high frequencies. And there are other things that we'll get to, but that really does capture the main ideas of filters, the different types of filters and their properties, and how we are going to be able to apply those to speech. Okay, and these are filters in the narrow sense, and the source filter, the filter in the broad sense, the source filter theory, that's the complex filter. That's all of these filtering elements combined into an overall effect. So in the next video, we'll talk about formants, and then we'll get to the source side of the source filter.